Thank you very much. So just to introduce myself a little bit, my name is Peter. I've been a PHP developer for about 8 years. Prior to that, I did a bit of C# and Java and that. So I've worked with, mostly the back end the entire of my career. If anybody here has used AutoShare, I was involved in a lot of their back end stuff. Lots of really cool stuff happens on the back end. But what happened is about a year ago we started doing, the company I worked for, we actually wanted to do a prototype iPad application. And we didn't want to invest in Objective-C, and we had to run it offline. And it turns out that AngularJS actually is really, really good for prototyping. And so being a web developer, I've worked with a lot of frameworks. I've worked with Prototype, with EXT, and the thing that's always bothered me is these frameworks often try to shoehorn in class-based hierarchies. So if you've done PHP, if you've done Ruby, they all actually have good class support natively. In JavaScript, it's generally shoehorned in. It's not like it's a native first-class kind of thing. So two things in my career kind of changed my direction. Like I literally quit my PHP job, and now I'm doing AngularJS full-time at Juice Mobile. And the two things that really threw my skills through the roof were Node.js and AngularJS. Node.js because I'm a back-end guy, I live on the console. Being able to play around with scripts so easily allowed me to kind of experiment and actually understand kind of how the language works, what its quirks are. And then AngularJS because it doesn't try to shoehorn you into a class-based hierarchy. So what am I here to talk about today? I'm talking about this. It's all over. And it's a funny thing, there are parts of the Angular source code where this just doesn't even exist. I think for the last few months, I actually looked over some code I did this morning. I haven't been writing with this. It's gone. So what's the problem? And I'm going to show you a couple of examples. Hopefully everybody in this room knows what I'm talking about and can kind of relate. The problem with this is it's this opaque, magical thing that just kind of appears in your code, right? Python, for example, said, no. The first parameter has to be self. So it's very explicit when you bind a function to an object. It's very explicit what this is. And in that fact, they use self. But in JavaScript, we actually have 4 kinds of method invocation. And this is kind of weird because you have one function type, but you have 4 ways of calling it. These are, so you can call it directly as a function, you can call it as a method of an object, or you can call it as a constructor function, or you can use these weird things called call and apply, which basically allow you to redefine the universe. Not really good things to do. But each of these invocation methods actually change the meaning of this strange, opaque, magical keyword. So the first one, I'm just going to go through these quickly because I've got some really nice stuff at the end. So function, unfortunately this is a little darker than I wanted, but you have a function called callMe, and when you call it, this is window. Okay, unless you have strict mode on, by the way. If you have strict mode on, it's undefined. Okay. So the other way of calling it is by a method. So you can bind a function onto an object, and when you say o.callMe, it's the thing on the left that determines what this is. So actually this is kind of cool because what it means is you can take a function, which is a first-class citizen, it's a value type. So you can take a function and graft it onto other objects, and you can actually share the same function across multiple objects, and depending on which object is on the left when you call it, you're going to get a different this. So, okay, cool, but it's very opaque to you, the function body. So we also have this constructor. So if you stick this little new keyword in front of the function name, it's magically an object, or some people call it a class, but it's really just a function. It's really just a function that creates an object. And this is an instance of callMe. It's not callMe. It's just like a child of it. And of course, if you have call apply, you can really do some strange things, and you get some weird, spooky, magical stuff. This actually, though, is actually one of JavaScript's powerful things. For example, you can pull toString off the string prototype and call it in with the parameter. Actually, a better example is you can take slice off the array prototype and call it in the arguments array, and you can actually turn arguments from its magical object into an actual array. So for anybody who doesn't know, arguments is not an array. Arguments is a weird object that contains references back to the arguments. So in fact, if you modify it, you can actually destroy the arguments that are being passed to you in a weird, spooky way that breaks things. So one of the things that I've found challenging in my career is when another developer comes to me and says, I've got this call. So you can imagine the set timeout is like a jQuery Ajax call or whatever, and they say, look, I'm calling this and I'm just setting this property and it's not referring to this anymore. What gives? Why is this? Well, it turns out that when you pass a function to set timeout, what it's actually doing is it's putting you on what's called the event queue, and it's going to be run later in global scope. So there's a couple of ways to kind of fix this. You can put var self equals this, and your function will now close around it. So you get this kind of weird, spooky magic where you're closing around it. Or you can actually, in browsers that actually support ES5, you can put after the last curly brace, you can put .bind this. But the reality is, you're shoehorning JavaScript into doing something it's not actually good at. JavaScript is an awesome runtime with an absolutely horrible language bolted onto it. So this is not always this. Arguments is not an array, and it's actually kind of difficult to explain to people who haven't hit their head on these kinds of things. So you end up actually, there's a lot of libraries out there that do this kind of thing. They're almost, paranoid that they're not going to be called correctly. So if this is not an instance of func, well, just call new one anyway. So make sure we're an object, which is, a clever workaround, but why are we working around? So there's a better way. I love XKCD, so mad props. Science, it works. So I've heard about functional programming for a while, but the first time I actually saw it, really prevalent in a really easy to use packaged framework was when I started using AngularJS. So, and actually this happened to me a week ago. I broke out my unit tests, and I was writing some filters because we're doing some interesting geo-hierarchical stuff that I want to be able to filter on. And I spent maybe 20 minutes running code, and I never reloaded my browser. I had my unit tests just spinning in there, so every time I updated my code, my unit tests would run. And it looks like and so filters are awesome. Filters, go look at the source code in Angular. It's one of the most beautiful things as a developer I've ever actually seen. So when you look at this definition, I say Angular filter uppercase. So I'm registering a function to Angular, it's called uppercase. And you have your constructor stuff, you have your package, which is a function. But all I'm giving back to Angular is I'm saying return function, string, and then when this function is called, just return the uppercase of the string. There's no, if this was Java, right, you might have an uppercase string format factory with about 500 lines of XML to define how to, scope it all together. But Angular just says, I'm a filter. I want to take strings and turn them into other strings. It's so simple. It's actually kind of beautiful. So you have controllers. I love controllers because they take your scope, which is the thing that's going to be passed to the view, and it just kind of gives it to you, right? This is dependency injection, so you're really calling something called scope provider, and it constructs a new scope. Actually, ng controller does it. But you don't have to say this. So when I put a little function on the scope called scope.alertGreeting, I don't have to refer to this, even though controllers are instantiated objects. I don't have to refer to this to get to data that's on my scope. In fact, every time I found myself putting this in a controller, it actually should have been refactored into some kind of service. It's just something I found out to be really true. With 1.2 and above, you have controllers as syntax tweaked, so you can say this. I actually just find that a bit dirty. I think that needs to be refactored. It's a signal to me that code needs to be refactored. And of course you have services, which are, again, they're packages of functions. My absolute favorite is factory, because you can really just return anything you want. $resource, for example, gives you back a function that when you call it, it looks up in a registry. It's really about composition. So what I'm talking to you today about is thinking about how we compose software and, getting away from thinking of object-oriented programming as classes creating objects. In JavaScript, functions are objects. Objects are objects. And we have this thing called, you have two kinds of inheritance. You have prototypical inheritance, and you have functional inheritance, where a function actually kind of inherits the scope of its containing class. And I just blanked the screen. So when you look at paradigms, and I hate that businessy word, but when you look at way of approaching software development, Angular is largely built around this concept called reactive programming. Reactive programming doesn't mean your boss runs in and says we've got bugs and you react to that. Reactive programming means you're actually thinking about data flows. You're thinking about how information moves through your system. So if you think back to the slide where I showed you the filter, we're looking at how a string is passed into a function and then returned. It's about flow. It's about connecting scope. So data flows, and in mathematics it kind of looks like this. It's a little expression. It basically says A is assigned the result of B plus C. Plus is a computation. B and C are inputs, and A is your output. So you can actually rewrite it like this. So you can say, if you give me B and C, I'm going to give you back some combination. In this case it's addition, but it could be multiplication and so forth. So I've used the word, I've said it over and over again, what is a function? In JavaScript, functions are values. Functions are these awesome little containers of logic, and they do actually a lot more than their class object counterparts. So closure is inheritance by association. Functions inherit through scope. So you're going to see this in my next slide, which is when you have a function within another function, that child function actually kind of inherits the variables that are around it. So literally it looks like this. If you think of classical kind of object-oriented development, you have the inheritable thing which the child can reference. So this actually happens a lot. People think classes are the blueprints behind objects. Well, functions are the building blocks of translations or transformations. So I hope a lot of people have heard about functional programming. Functional programming in a pure environment is you have a function, ideally it has one input, it produces one output and causes no side effects. The beauty of this form is it makes testing so much easier. Unfortunately, JavaScript is not pure, and we just have to live with it. There are performance reasons why you would actually fall back to using this. It's kind of unfortunate, but it's necessary. So this is actually something I wrote just a few hours before coming here. And this is how much I love it. So you can see at the top, I have a function that takes an item. What is an item? It's basically, I have a problem with select to configuration in Angular, where I wanted to basically pull from an Ajax result, but my result came in format of item key, item description, and it wanted it in format of ID text. So all the function does is take an object that has a key and a description and translates it into an object that has ID and text. And then I can do this weird spooky thing, because if you've never seen functional programming, I compose a new function that says, I'm just going to point this out, copy something, because it's right associative, onto my configuration. And then before you do that, call this thing and map it. I've got a slide that will clarify this. But I actually wrote this, and I think it's awesome how you can take little small utility functions and just kind of compose new functions by associating them together. So if you've taken math, you might know that f composed with g is like calling f with g at x. Well, g, that looks like code to me. You know, and we all know that you call G first, and then the result of that is put into F. So it's all about gluing functions together, right? Here I have two functions. I have an increment function that takes an x and returns an x plus 1. I also have a function that multiplies a number by 2. So I can say, you know, increment by 41, I'm going to get 42. I'm going to multiply 21 times 2, and I'm going to get 42. But does anybody understand what this last line is doing? It says compose console.log times 2 increment, and then it kind of goes out. Well, it actually is doing this. So the top and bottom lines are actually equivalent. A lot of people, when I say I love JavaScript, they actually say, don't you hate nesting functions? Well, it turns out that functional programming offers us something called compose. And the challenge is you have to read it right to left, not left to right. So if you forget this for a moment, I'm composing a function that will take a value, call increment, take the result of that function, multiply it by 2, and then feed it into console log. So you're literally composing functions together, and so you can see how it relates to other programming. So it lends itself to something called partial application. So if you take a function like this, right, you're tightly coupled. I'm doing a lot of things in here, I'm embedding this, so ultimately I can only say hello world. What functional programming would offer you is the ability to do this. That partial says, take the function greeter and give it a default first parameter of hello template, which is my template. What's cool is this gives me back a function that whenever I call it, it's going to call that function, and the first parameter is always going to be hello template. So I can now make a specialized function that combines these two things together, the greeter and the hello template, and gives me back a function I can just throw around my system and actually make it more testable. By the way, I'm using Lodash here. Lodash is equivalent to underscore. I hope that if anything I say here, you just go kind of look at these libraries. They offer a lot of really good functions. So I'm going to skip over that because I'm running short of time. One of the shortcomings is, unfortunately, currently a lot of this stuff it's not poor performance, but it's not as well performing as its kind of raw counterparts. However, ES6 is introducing this stuff as native, and it's got some really slick syntax. Unfortunately, it also introduces classes. So watch Douglas Crockford, he talks some really good stuff. This is what ES6 looks like. You can actually use a program called TraceUR to kind of run it. So you can see they're actually cleaning up a lot of things. You have, I can't remember the names of these things, but you have basically an operator that can take all the rest of the args and actually gives you a real array. You have the ability you have this arrow syntax, which is basically a very shorter way of writing a function. So they're obviously taking functions very seriously. Compose, so I showed you a slide with compose. This is my attempt at an implementation of an ES6 compose function. Yeah, I have a little bit of time. So the outer function compose is just a function that takes a list of functions. This function returns a function, so you can call it. It's essentially bounding of that list of functions to this inner function. This inner function takes an optional array of arguments and then says, well, I'm just going to take these functions, this array, and I'm just going to go backwards over them. So from the rightmost one to the leftmost one, I'm just going to call it, I'm just going to keep feeding them into each other. So you get this nice compositional chain, and ultimately I'm just going to return the final value. So you can see it's kind of neat. You can get, that's what functions look like. So my biggest hope with ES6 is that, one, that it actually comes out, and that 2, Internet Explorer supports it, and that 3, performance actually, this drives the performance issues that some of these, that functional programming is having in JavaScript. So I kind of rushed through things a little bit there, but I wanted to fit in 20 minutes. And so just some resources. I definitely, one, look at the source of Angular. There's some things in there that are absolutely beautiful. like really simple, well-refined, very well-written stuff. Take a look at these libraries. They offer a lot of functional programming. They're different ways of, again, it's about how are we composing, how are we communicating, how are we building our logic. There's some really good guides, and if you're interested in ES6, go play with TraceUR. They've got a really excellent website. So that's my little spiel. Thank you very much.